Hey everyone, why is there so much space here in the front? Maybe someone wants to come closer? No? No? You're all introverts? Okay. Welcome to our MDL number 18. We are here in Workland, Latvia, which is a really nice co-working space. So pay attention to it in case you need a co-working. And yes, no, first let's do a small workout, warm-up. And put your hands up if this is your first time at an MDL event. Okay, more people not first time, which is nice. Means you like them. And put your hands up if you are an Android developer. Okay, about half. If you are a Flutter developer or you want to be a Flutter developer. Okay, any other kind of developers? Put your hands up. Okay, that's interesting. Welcome to the mobile world. And so, yes, we are here mainly for two things. For, of course, first of all, building a community. It's really nice to see all kind of developers, I guess not only mobile developers, being together in one space. And also, of course, is to share knowledge and invite top-notch speakers with top-notch content. So also take advantage of catching them when networking, asking your questions, just talking to them. And by we, I mean Chili Labs. We are the host of this event. And what we do is we are an agency that builds mobile apps, all kinds of apps, Android, iOS native, Flutter, of course. And we also do turnkey development, starting from design, design review, testing, and everything there is to do. And we are always hiring. Currently, we are in search for both junior and senior mobile developers of all stacks. So you can check out specific positions on our website. And if you or your friend or friend of friends or anyone who you know are a junior marketing specialist and looking for this role, this is also someone we are happy someone to join our team. Okay, and this is a white slide. Okay, one little slide is missing, but that's not a problem. So I just wanted to remind the agenda for today. We will have first talk by Tato. Then we will have a small break, coffee break, where you can network with each other and with our speakers. Then we'll have a second talk about Flutter by Raitis. And there will be even more networking time. Okay, and with that, I want to invite Tato, who came to us from Germany, but also from Georgia, but I guess he will tell more about it. And he will teach us a bit of Android development.
Hello, thanks for inviting me. So today I want to talk about the composable build logics. It's a topic about the Gradle conversion plugins mostly. But before we start, I also want to talk about a bit myself. So I'm Tato Kutalia. Originally, I'm from Georgia. I'm Android GDE, and you can find me on Twitter if you have some questions regarding Android, or sometimes I also post like latest stuff, what's happening in Android on Twitter. So make sure to check out the profile. I know the Twitter now, it's becoming a bit old school because like there are some Mastodon and other alternatives, but still like Twitter is like where I stay. Also, I have some cool stickers. Maybe you can take after the talk, like Flutter, Dart, Android, Kotlin, like all the stuff. So it's here. It's not visible, but yeah, it's here. Also, I talked almost similar topic, like which is like one like prerequisite before approaching the convention plugins. It's called the Gradle version catalogs, which is like also the new thing. I had this talk at the Android Makers in Paris. So if you are curious about the version catalog, how we can migrate to the version catalog, how to optimize it, get the updates, automatically merge it like with the bots in a pull request, check out this talk from me. Yeah, it's like lots of self-promotion, so let's get to stuff. So why is this slide? So last few weeks, The Legend of Zelda became my part-time job. So if I miss something in the slides, like preparing the slides, any kind of info, we can continue the networking session. It just like Legend of Zelda took almost of my time preparing the slides. And yeah, like on the other hand, instead of Gradle builds, I have really awesome builds in the Legend of Zelda. So like talking about the trade-offs, I'm not I'm not against it. Before we before we actually dive into the topic, I want to open this QR code in Meetup because I want to evaluate what's the perception about the Gradle stuff, how you think like about the Gradle, and what are the feelings around it. So let me share this. It's not sharing. I'm in the presenter mode. Okay. Yeah. So the first question is, what words are coming to your mind when you hear Gradle? So please take like 10 seconds to come up with your own. Yeah, totally valid. I'd say totally valid. So, the Android. Suffering, yeah, pain, yeah, totally related. Oh my God. Java miss, oh my God, yeah. PubSpec? Wow. Yeah, so basically, I see like the suffering, pain, like all the synonyms. And one of the reasons why I'm here is to talk about how we can remove the suffering from our everyday life. So we can't really eliminate it from our from everyday, like from job, but at least we are not going to struggle every day. And also, like Android developers will understand that if they worked on a large project and also on the old project, they understand how Gradle scripts changed like in different years. For example, in 2018, if you have some scripts from 2018, it was like quite messy, quite bad. And now at the end of 2022, there are like the KTS, like Kotlin script, like different ways to write the task. And it's like, basically they should be same, but also it's like completely different like the language and how it was, described. So, okay, moving on. So what is the, what do you use to maintain the build logic? This is another question. Like the last option is that if you don't use the Gradle, that's also okay. If you use Bach, Bazel, yeah, it's cool. But yeah, what I'm curious. Wow, convention plugin is nice. No one with build SRC? No one? No one with build sources? Wow. I didn't expect that. Wow. Everyone is writing on with convention plugins, so like this talk is irrelevant. I can go home. So, okay. The good thing is that, yeah, I see the convention plugin adoption. I love it. But I don't see build source. It's also good, but I think that to fully appreciate what the convention plugin is doing, either you should be writing the build Gradle before on the build sources. So let's get back and actually see what happened in Gradle and how we can improve our build logic, like to make it more composable and also cacheable. So usually when we start the project, it's like, this is a sample from the Now in Android, this snippet of the graph. I built the dependency graph from the Now in Android. So this is a snippet. So imagine this is the start of the project. So you start with a few modules. In the beginning, you want to like modularize to be on the correct path. Like, let's not discuss if the modularization is in the beginning is like the correct or not. Let's say that we started the modularized project and we are on the correct path. But after some time, the project grows, complexity increases, and we have something like this. And still, it's pretty like mediocre application, not that big. This is the current state of the Now in Android project. So for those, if you don't know what's the Now in Android is the showcase application from the Google team, from the Android team mostly, the DevRels. and development engineers that showcases all the best practices from the Android, starting from the Gradle convention plugins and the version catalogs, and through to the materials tree and the compose and all the cool stuff, and all like the GitHub Actions, CI/CD, and everything. So go check out this project. It's a super cool project. So this is the current state. So after some time, we started configuring projects in a different way. First, it was the Gradle files. Then we added, like in 2019, probably we started adding the KTS, like the Kotlin script, because it was cool. So we started like the Kotlin script. Then we also had another option because we had very old answers on the Stack Overflow that we could do everything in the all project or sub-project block. So we had this mixed all project block plus the Gradle files and like the custom scripts. And also then a bit later, we added build source to contain the logic. I've seen projects where all of this stuff is mixed together. I also saw projects like containing the build source quite well before the convention plugin, but this is how usually we configure the projects. But in reality is that we have the Gradle files that no one understands, except maybe one old senior developer in the company. Then there's like a bus, if you heard the bus factor, like the bus factor is very high, and the bus factor is that what happens when bus hits the developer, is your project like the frozen, like who can maintain it, because only one developer knew all the Gradle scripts and how to write them. So the Gradle scripts no one understood. Then we had the all projects and sub-projects complicated block. So if you have not noticed the all projects, what's that is that in the main root Gradle build Gradle file, you have this block all projects, and with a simple, like the tasks or the single one-liner commands, you can configure all the sub-modules of the project and apply the same, for example, plugin, the same task, or do some kind of manipulation on the common tasks if you want to filter some task when one flavor is selected, like removed some other tasks from the configuration to make it like a more intuitive for the whole team, like all kind of logic. And lastly, build source contains all the logic. Nothing wrong with the build source until now, I would say, because it was the best alternative what we had. But build source is kind of not the best replacement, because we always lose the cache when we have the build source. Like when we want to update something in the build source, to change anything, it needs to be recompiled. So it means we are losing the cache, and because build source is like the core, like we lose lots of cached stuff in the project, and we have to rebuild it again on the CI and on the local machines as well. So not ideal. Plus, having everything in build source is like not ideal because, okay, it's Kotlin, but still like we need more decomposition to like reduce the pull request size, to increase the readability across the teams and developers. So I imagine like if one person is maintaining the project, then it's like okay for that developer, because this developer is in charge of everything. But to scale this to the like almost 10 different teams for 20 plus developers, and they work like autonomously, they need like the quick pull request reviews from the different teams, less merge conflicts, less broken builds. In that case, build source is not the ideal solution. So this everything accumulates, and at some point we have this mess. So this is not now in Android projects. This is like one of the projects I worked is like, it's not the worst case scenario, but it's not the best case scenario either. Like we have lots of modules there, lots of interdependencies. This can be cleaned up perfectly, but this is a different topic. by the way, if you want this kind of representation of your projects to see what's going on in your project, I suggest to use the Gradle dependency, like how it's called, builder, to extract the dependencies between the Gradle modules and then import it in some kind of graphic visualization tool for the graphs, for example, Gephi or other stuff. Generate this, and then you can use graph manipulation algorithms like to highlight the populations, like the heavily connected modules with each other, and basically you can analyze your graph, the dependencies between the modules. But this is also a very different topic, and this is not related to us, but it's just if you want to analyze your own project. So what if we had like composable, also standardized, like all the good standards from Gradle, shareable, and everything together in one build logic, like no scripts like spread across the project, like just what we call build logic. This is yeah, like I'm obsessed with this GIF. The office, like anyways. So this is what convention plugin gives us. Basically, convention plugin, the philosophy is to use the convention over the configuration. So therefore, it gives us the composable architecture, not the Jetpack Compose, but the pluggable composable stuff, and also the standard API by Gradle. So up until now, across like 5 years span, we had like multiple APIs from Gradle changing all the time. Every developer wrote even the same script in different manner, in different languages, in different place, applied to the project, like for some like in some weird conditions for like at the end of the file, or in the beginning of the file, like at the end of the configuration cycle, and like everything was crazy. So now we have like the standardized way to do it. And also we can share this build logic, like share, because it's composable, we can apply like this our specific piece of logic to this specific module, and that's it. Like we can encapsulate this, and if we need it, we can compose them together. Back to the Now in Android project, this is the best highlight I can give you right now. So they implemented these convention plugins in multiple scenarios, and here is the, for example, Android Compose, Android instrumented test. Like it means that you write Android instrumented test specific build logic there, or Gradle managed devices specific logic there, and they can be used separately but also together at the same time. Usually, what the people were doing is that this Gradle managed devices is also the new API, so it basically allows us to define the specific emulator, also for like the remote emulators, and we can always start the tests on these emulators and also benchmark tests. So this is a new API. So what the people were doing is that putting this automatically where the testing configuration was in a Gradle script, and they were using everything together. If we needed something, there were two options. People were just copying everything in a new Gradle, or extracting as a common Gradle script somewhere and apply in every module this, which is not the perfect solution. So this is like the more mature solution where we have like extractable piece of logic that can be applied at any point in time for any module. So it's a benefit. Same applies to Choco and also the Kotlin Android stuff. So let's start with let's start reviewing the Android Compose file. Hence, it's in Kotlin. So we are benefiting all the type safety, all the type system, everything and the autocomplete, of course, from the Android Studio. So better than writing the Groovy scripts, and also sometimes Groovy scripts were very dull in Android Studio. You have to reopen Android Studio to get the autocomplete, or wait for 5 seconds to get the autocomplete. Like it was terrible. So what this piece of code is doing, it is what we are doing basically in Gradle scripts. It just we copied in a Kotlin and moved here in some kind of function to apply it whenever we need. It specifically this applies compose related dependencies and the configuration. At the first line, of course, we are not going to go through this file like line by line, but to give you the context for this one is that the first it takes the version catalog. Again, version catalog is a cool thing. You have to check it out if you have not yet. So taking the version catalog and then gets the specific version from the version catalog and applies the dependencies and also configures the Kotlin compiler options like on the bottom we have these free compiler args because we need the compose metrics. So it's very specific for the now in Android project. So another file we have the Kotlin Android, which obviously applies Kotlin Android stuff only, which is by default we apply the Kotlin and then we need the core library desugaring because to desugar all the high level APIs to the lower level Java APIs, and also we need these compile options and so on and so on. So basically that's it. And we don't need to copy this, and we also don't want it to be the common script which you need to always write. Apply from this .gradle, apply from this, and like crazy stuff. So next one, also let's review the last file from this. It's the Android library compose convention plugin. Name is great. Like you shouldn't expect like any short names in the convention plugins because it should be like the expressive, like always should express them be verbose compared to other class files. So basically what we are doing here is that we are building the plugin and just apply what we need. So for this example, we need the Android library, like because we are doing the Android library compose plugin. So we always need Android library. And then we are using the configure Android compose, like we are calling configure Android compose function, which we had here, configure Android compose. So it means that now the plugin can call this function which you had, like the utility function, and then like we can apply this plugin wherever we want. And if we want to change something in the function, it's very easy to do in a Kotlin code base because all the features Kotlin provide to us compared to the Groovy scripts. And this is how we apply. Hence the plugins blocks. This is plugins new DSL from Gradle. So, and also see the plugin ID is now in Android, android.feature, library compose, Jacka.comp. So those plugins are not published in a Gradle plugin repository. Those are all local. It just we define this plugin name in our project and see how composable it is. Like we don't need to, like we'll talk about a bit later. So clear distinction is that like instead of applying custom scripts, we have the plugins, and that's it. It gives more clear code in that sense, and also very easy to change. Plus, the convention plugins are cacheable, and we will also going to talk about this. So yeah, so library Jacka, the compose build logics are decomposed. We can use whenever we want only Jacka, only compose, or only the feature configuration, or we can also include them together. So let's implement this convention plugin by ourselves. This is a very basic example how we can getting started with the convention plugin, but basically that's it. Like you just need simple Gradle plugin, some Kotlin code, and that's it. So first we need to create the Gradle plugin, which is like can be the new folder, the build logic, and just configure build Gradle there and also settings Gradle. Pretty straightforward. If you build any plugins, like that's it. if you have not done yet, just copy one and that's it. Like we just need Kotlin DSL to depend on the plugins. Obviously the repository to pull the dependencies. We need some compile time dependencies because we have to like compile our plugins as well, and it's just a compile time dependency, not the binary dependencies. And also we need to declare our plugin ID, what we use, like in the previous example here. Now in Android.feature, something like this. So the ID and the implementation class. That's it. That's it. Now move to the, of course, the settings Gradle in a root project, just to add one line. This is the include build logic. What it does is that compared to other, like the build source and others, build source were just the part of the module, and when it changed, it required to recompile and lose cache. Here we have this as an included build. It means that it's a separate project, and if something changes, we need only to recompile this plugin and nothing else, and we don't lose that cache. And also inside that build, many things are still cached, and like the only minimal changes will be applied and recompiled. So like the compiler avoidance actually working well there. So this is the only line you need. So a huge improvement on that one. And also it will save quite a lot of time on the CI machine. It depends on the size of the project. Of course, if you have like 10 modules, it won't do that much. But if you have like 200, 300, like for example, in our current project, we almost have like 300 modules. So it kind of makes sense to have this to always take care of the cache and also have this decomposed stuff, because like configuring that many modules is kind of hassle in the end. So let's go through the code. It's also very simple. First, we are creating basically extending the plugin, because we are plugin project type, because we need this for the project. And override one single apply function, and the project is a target itself. So basically this is a Gradle project, the module itself, and we write everything like we did in the Gradle scripts. Just one difference: we have the Kotlin here and all the support from the Kotlin. Apply. Let's write the compile SDK. Let's apply the default config here. Also the compile options. We can also split this stuff, but because we are configuring Android application here, makes sense to have everything together. And yeah, that's it. For example, this configures the main Android application. Again, this screen, because this is what's happening in our Gradle. We just wrote this implementation class and ID, nothing else. And this is how we declare it. Like from the plugins, this ID, that's it. And eliminates all the setup from the Android application, like build applications, build Gradle, and everything is moved in the convention plugin. So at the end, we can get something like this. So application, decompose, Choco, healed, because we have modules where we don't need healed. Sometimes we need healed, like the Choco. There are plenty of modules where we don't need Firebase performance metrics, and we don't want to mix these Firebase performance metrics with other projects. For example, still, I've seen the code in the all projects blog where people configure the testing, the Firebase, the everything else. So now it makes much more sense. Let's analyze. So we got the codes that we can change once, and it will be reflected on all the modules. Plus, we also retaining lots of cache. It's maintainable, retaining cache. It's typed, so we have the Kotlin type systems there, and it's testable. Voila! One little note on the tests before we move on. It's like not all plugins require tests or can be written tests for them. So let's talk about why. So testing tasks and the plugins. So Gradle is a different beast. It's not really easy to test Gradle. So there are very few articles, mostly it's from the Square and like some huge companies where they like have good enough capacity to invest into the testing and also scale this across the module. For example, last year Square said that they had more than 3,000 modules and they maintain the build logic for it, and also like it's extendable, testable, and they need to reproduce this for every module, for every Gradle version. If something breaks on a Gradle 8, then they need like concrete reproduction why it's happening. So how we can test the Gradle tasks? Not the plugins, but the tasks. We have test kit from Gradle itself, and usually it's a functional test. What does it mean? Like, we have few options to test the tasks. Like the task, I mean any kind of task which has the build output, like output something on the print. Basically log something during the execution, or they write something in a file, or it executes other tasks and we can check their results. For example, if the task failed, if it's skipped, if it's like executed, whatever. So in that case, for the convention plugins, we don't really need tests or can write tests because our convention plugin in this case is only applying, oh God, it's too far away. Basically, we are only writing the configuration phase. But if we had some kind of task which executed, had the output, then we need to test those, and test kit provides us the functional test to write this. And benefit of this is that we want our Gradle task to also survive configuration cache and have the configuration, because in a new Gradle, configuration cache will be enabled, and there's still many Gradle plugins which doesn't like really provide the plugin, really support the configuration cache, and we want this to have the configuration cache to be independent. It means that every output should, like what we give for the input, every time should give the same output. So this will help us to test this behavior. Okay, now let's talk about the real stuff, the migration and the tips and tricks, and what I learned from migrating multiple projects on convention plugins since like at the end of the last year till now, and it might be useful for you if you are like want to migrate the existing project. First of all, you need to change the apply plugin, this kind of syntax, to the plugin DSL, new DSL from Gradle, and there's the asterisk. If you notice, it means that. So Gradle comes with some caveats. Like the plugins block can only be used with the project's build script and the settings Gradle file. It means at some point, if you have like custom Gradle scripts which are not in a project build file, I mean, if you have like common-library.gradle, which we're configuring the common libraries, common code, like assigning the version, designing the common dependencies, handling transitive dependencies, stuff like this. Plugins block will not work there for now. This is a huge problem, and automatically this stuff like makes our problem a bit harder to migrate, and how we should approach it. So now we need to refactor some basic building blocks first, and then approach the common scripts later. Take this example. We had the common library Gradle. This is quite an old code, but you see the idea, what was happening there. So basically, we were applying the standard Gradle plugins, the library, Kotlin Android, and then we had some custom scripts like the K2Lean, coverage, license, which were applying just the script files, and then we configured everything. So it means that in this common library Gradle file, plugins block will not work. Okay, now question is, okay, let's remove all the apply from stuff and move to the plugins block. But no, because it's a Gradle script like the ktlint.gradle, it's not a plugin. So we cannot really apply this file to the plugins DSL because plugins DSL only take plugins from the Gradle repository or from locally. So what we need to do is first refactor the ktlint into the plugin, refactor coverage Android into the plugin, refactor license report into the plugin, and on the second stage, we can refactor the whole common library Gradle script, and we can have everything like the plugins there. So this is like the project currently I'm working on. So now everything is a plugin, and the one layer up this containing script is also becoming the plugin, and we can configure here. So now we have like the first bits of composability here. Another one. So now we need to, like, of course, like I already talked about this, we need this compose script to be adopted, like these common scripts to be adopted in the build Gradle project already. So what we are doing is this, of course, we are converting this to the plugin. So we can use the plugin DSL. But the problem is that now you cannot use conditionals there. If previously you had like if something or like if execute some task, detect maybe. The good example would be detect, is it a Huawei related build or is it a Play Store related build? Like we have to distinguish, and we don't want to mix the dependencies and everything into each binaries in the end because of the Play Store and the Huawei's policies. So at some point you had if something, then apply this, else apply that. But with plugins DSL, you cannot do this. So we need another layer of the plugin to configure this logic. So like okay, if this is happening, then apply this piece of logic, which is already plugin, else this. And like it is a hard work, the manual work in the beginning, but at the end, everything is the composable, and like the very few pieces here and there that can be changed without breaking everything else. Oh, and another good catch is that you cannot mix plugins and apply from. So if you think that you can gradually migrate some stuff, you're wrong. Either do everything together and jump into the cold water, or break up your Gradle build that way to somehow extract the stuff that you can work with that. Like there is no other way. So the plugins and apply, these two different DSLs, like two different syntax, should do the same stuff to apply the plugins, but they are not interchangeable. They work differently. Apply from syntax is obsolete already, so it's not recommended way. Recommended way is the plugins DSL, but plugins DSL doesn't provide enough like the ways and also the capability what the apply from had. Standard Gradle way, sorry. And just another note is don't forget update some generative scripts. For example, of course, if you are scaling your application, you have like some bash scripts or whatever to generate your modules, to generate your configuration, and you don't want to waste your precious time on this dull stuff. So make sure to update them, and like basically insert correct plugin configurations there. And also one cool stuff is that you can use type-safe accessors within the Gradle. What is a type-safe accessor? It's just a neat feature from Gradle which helps you to define your internal project, like the modules, like you would use from the version catalog. So these utils and the API is your utils module and the API module, but you can approach them as a project.utils, project.api. You will have autocomplete support, and if something changes, of course, it also breaks here. It will be underlined here because Gradle can't really resolve that module, so you'll have more safety not to break build and catch errors earlier before reaching somewhere else. So yeah, expect big changes. For me, it was like this. For like medium-sized project, it's not a large project. Like still, like we have almost like 250 modules, but still, like it's not that big project. So expect these changes, but most of the times changes are trivial. Once you sort it out, all the convention plugins, then it's very easy. You just need replace all script to replace all the modules correctly with the correct naming, and that's it. It's like one-liner changes. So yeah, the resources are here. Now in Android, perfect. The convention plugins, you can read more in the documentation. The very good Square blog, Herding Elephants, it's actually, they have like 2 different parts of the blog. Very, very nice blog, 100% recommended. And also how to test Gradle plugins. The blog also written the same author who wrote the Square blog. And at the end, like at the end of the slides, because of like listening to me, and the Gradle stuff, it's not that easy. Here's like the Korok seed, like if you are all obsessed with the Legend of Zelda. But yeah, like those things are very hard to find. So I spend lots of time finding those and solving all the cases. But yeah, here we go. Thank you very much, and yeah, I'm waiting for your questions.
Can you please repeat the question into microphone, okay?
Okay.
Questions? The hand up. Exclusive opportunity.
Yeah, otherwise we also can talk outside the room in the networking session. So yeah, that's all from me. And yeah, make sure to take some cool high quality stickers from the desk. Thanks, bye.
Thank you very much, Tato. Thank you for this insightful talk, and I hope that Gradle will become less painful for all of us. Thank you.
I know.
Okay, be sure to catch Tato there in the networking space and ask your questions if you're too shy to ask them here. And we will have a small coffee break, and the time there is incorrect. Let's get back at 1940, okay? 1940, back here for the second talk. Все? Начинаем? I just want to invite Raitis to stage so he can teach us how to manage our memory in Flutter properly. Let's welcome Raitis.
Okay, first time using this. Okay, it works. Hello everyone. It's really nice to see you. A lot of familiar faces in the audience, a lot of new ones as well. That's cool. Welcome. Today we are going to talk about memory management in Flutter. My name is Raitis. I'm a mobile iOS and Flutter developer at Chili Labs. I have made 2 Flutter apps myself, Kitchenette and OrbitGuard. OrbitGuard is actually a game. I played around with Flame game engine for that one. So if you haven't checked it out already, please do. Share your feedback and help me make this game go viral. Usually I play basketball, but I've been doing kickboxing for quite some time now. So be careful around me during the networking. I'm just kidding. Don't take me that seriously. Let's connect on social platforms. For example, Twitter. I'm not very active in terms of tweeting, but I'm trying to become more active day by day. So we'll see how that works out. Yeah, today's agenda. We'll talk about how can we tell that our app is leaking memory. What is actually a memory leak and what characteristics does it possess? What is the role of objects and references? Also, how is memory allocation and deallocation happening within our apps? What can we do to find the source of the memory leak? And what can we do to potentially avoid memory leaks in advance? So, okay. Can I ask you, please raise your hand if at any point, whenever you were using an app or developing an app or just testing an app, have you ever experienced performance deterioration of the app by experiencing frame drops or app freezes? Like, can you raise your hand if you have? Okay, cool. What about app crashes? Yeah, especially the ones with out-of-memory error in case of debugging the app. Let's just add one more, like increased battery consumption. For example, app is putting too much of a load on a processor, although it shouldn't. And in case you have experienced at least one of these problems within your app, chances are that your app was actually leaking memory. So what exactly is a memory leak? It's basically a condition whenever application fails to release unused memory so that it could be allocated for other resources. So is that the definition clear enough, or should we do like a practical sorts of example? Can you raise your hand if it's okay enough, or I don't believe you. So okay, let's do it like this. I want you to clap your hands, but don't release them. Like, put down your glasses and bottles, but just do it like this. Okay, memory gets allocated. If you want to clap again, we have to release our hands, right? Memory gets deallocated. Let's clap again. And this is where memory leaks happen. So in every good application, especially on the enterprise level, memory management is vital. Too soon? So when talking about, let me just check, I'm sorry. This is not going to work like this. Okay, so when talking about memory management in general, it happens during the runtime, mostly. And the memory that gets allocated and deallocated into the memory happens in the random access memory of the device, also known as RAM, right? Not to confuse memory leak with memory bloat, which actually is a condition whenever too much memory gets used for something. For example, loading too much data into the memory. Let's say we load a large image into the memory and never dispose of it afterwards. So basically, memory leak is like a gradual increase in memory consumption over time, but memory bloat is rapid, sudden increase in memory consumption. And then it just plateaus. So when talking about objects, we can separate out Dart-specific objects and Flutter objects. I guess, can you please, I'm sorry, but can you please raise your hands again? Who of you are Flutter developers? Okay, so I guess at least most of you should have heard by now that at least someone said that everything's a widget in Flutter, right? Which technically is not true, but sounds cool nevertheless. And when talking about objects in Dart, you can actually say that in Dart, everything is an object, because it is, apart from null, of course. So everything from strings, booleans, integers, to maps, lists, and so on, everything is an object in Dart in context of objects. The difference between Dart objects and Flutter objects is that Flutter objects come with their own unique set of characteristics. For example, a widget comes with the lifecycle methods. It's immutable, and it can be associated with other objects like state, which in fact is mutable, and so on, just as an example. So we can divide objects into two categories based on their lifespan within the app. There are short-lived objects and long-lived objects. Short-lived objects are created and destroyed frequently, and they can be anything from local variables that are defined within the scope of the functions, also UI state, iterators, and so on. Long-lived objects, on the other hand, are garbage collected less often because they persist in the app for longer periods of time, and usually they are global variables, app state, controllers, and even cached objects. Okay, let's talk a little bit about object references. So, with every Dart application, a root object gets created. And it references every other object that gets allocated into the memory. So, and since root object is the entry point of garbage collection, okay. I'll just leave it open, I guess. Okay, so root object is the entry point of garbage collection, so that it, based on references, it can, like the garbage collector can understand which objects it can collect and deallocate the memory, release the memory. Okay, so the references between, okay, so something's not quite right with this one. What is the next slide? Okay, What did I miss? Okay, let's do it. Let's do it this way. So, what is retaining path? It's basically a sequence between. It's a sequence that is formed by references that are pointing from one object to another. There are reachable objects and unreachable objects. Reachable object is an object that has at least one reference pointing to it, which means that it's currently considered to be in use by the app. Also, it's seen to be in use like by garbage collector, and that is the reason why it cannot be garbage collected. Reachable objects become unreachable when there are no more references left to them. So basically, unreachable object is not used anymore, and it's eligible for garbage collection. So, okay, about memory allocation. Okay. Sorry. Yeah, so memory allocation is basically a process of assigning portions of virtual memory to executable program. In other words, it means that application needs memory to be able to execute its commands, do some calculations, also store and manage some data. When talking about memory allocation, we can divide it in two categories, like static memory allocation and dynamic memory allocation. Static memory allocation happens during the compile time, meaning that all the objects that are created must be of, no, not must be, but they are fixed size, meaning that they cannot be changed during the runtime. And mostly constants and static variables are the ones that are allocated statically. Dynamic allocation, on the other hand, happens on the go during the runtime of the application. It sort of adds flexibility in terms of memory allocation because of in terms of size, and the objects are allocated only when it's actually required. So, since Dart is a garbage collected language, its runtime comes with garbage collector. Garbage collector essentially garbage collector essentially just makes sure that so garbage collector essentially just identifies which objects are no longer reachable, and like releases the memory from them and keeps it available for any future allocations. And garbage collector, being the automatic memory manager, means that developers do not specifically need to write memory management tasks, at least not in traditional sense. You don't need to write the code to manage memory specifically when it comes in terms of in context of garbage collector. In terms of garbage collector. So you can basically look at garbage collector as your sidekick, as a behind-the-scenes hero who cleans up after you and always, well, almost always has your back. If you want to know more about garbage collection, I highly recommend checking out this talk by Anna Lushenko. It's she basically covers everything, the ins and outs of garbage collection. It's very insightful, very detailed, and very well very well illustrated. Okay, so dynamically allocated memory is stored in Dart's heap. It's operated by the operating system, which means that its size is limited to the size of virtual memory. And whenever memory overflow happens within the heap, memory leak occurs. And it's also the memory of the heap is managed by Dart virtual machine, which means that it's allocated on the creation when the app is loaded, and released when it's no longer of use. Okay. So, what can we do to find out the source of the leak? Well, we could use debugging tools provided by Flutter and Dart team, specifically DevTools memory view and leak tracker package. Leak tracker package is relatively fresh. I would say it's still pretty much in development. But yeah, let's take. Okay, so I guess White Ninja says that we need to do something. So let's quickly do something. Whoop! You shouldn't have seen that, but I guess it's okay. Just my notes. So what we have here is, I hope, can everyone from the last row can see it? Okay, it's cool. So this is DevTools started up in a browser. And what we are interested in is specifically memory section. One thing to mention, to point out, is that I'm running this app in debug mode for the purposes of the demo. But if you want the most accurate readings, you should always test it in profile or release mode. So what can we see here? Let me just pull this a bit down. Can we make this bigger? I guess not. So there's this graph timeline of, this is basically a memory chart. What can we see here is resident set size. For example, it's the memory that is loaded, that is available for immediate use. This orange dashed line, and what we will focus on is the blue wave, like the size on the heap, memory size on the heap. The tabs that we are interested in is profile memory, also diff snapshots, but I won't cover this today. Trace instance and detect leaks. Detect leaks is only available through leak tracker package. And it basically tracks leaks within your app and the most common leak types, the ones that are not disposed, not garbage collected, or they are garbage collected late. So, little backstory of the sample app. There's a leaking container which will be removed from the widget tree and inserted back into the widget tree when tapping on the toggle container button, the red one. Underneath, it uses a text editing controller, which is not properly disposed of. And when pressing the blue button, increase leaking objects, we are going to generate 10 million objects and store them in a list of a singleton object. Okay, let's try this out. Hopefully it will work. So if we do this a couple of times, we can see that our app is leaking memory. As you can see, 4 memory leaks identified, none of them were disposed. And what we can do is download this and analyze the stack trace of our leaks. If it will open, Yes. So, as we can see here, total of 4 not disposed objects, text editing controller, as I said, identity hash code, not really useful for us, at least not for today. And if we look carefully at the stack trace, it's pretty huge actually. But since I know the name of my widgets, I can easily spot it here. And so basically it tells us where that leak is kind of coming from. And so this is about leak tracker package. Now we can go back to memory profile, to profile memory. So what we want to do here is look for unusual amount of instances and total size created. So let's see if this works as it should. As you can see, there are like many leak objects, instances of leak object. They take up more than 120 megabytes. And yeah, we have 10 million instances of leak object generated. What we can do here is, obviously we could search it in our code, but from the DevTools, we can go here, like filter out leak objects, find it here, check the checkbox, say that we want to track it, select it, and when the next event is fired, it should return the code path. If everything, yeah, as you can see, we can see here the code path. In my case, it's not very long because, as you can see, it just returns unincreased leaking object. That's the method where this is happening. So, yeah, that's basically how we can start at least locating our leaking memory. Just try to find the culprit and potentially fix it. Let's try to crash it real quick. Okay, maybe it's not going to crash. Probably it will though, but it's going to be in the background. Okay, let's return to this, the presentation. I came prepared with the backup option, backup option 1, backup option 2. Okay, so we're finally here. What can we do to optimize our memory? Sorry. To optimize our memory, there are like several techniques and methods. What we can do to potentially at least limit the chances of memory leaks. Okay, first one, we could try to use weak reference. What weak reference does, it creates a reference that allows, it allows for the object to be garbage collected even it has reference pointing to it. And how it works, basically you wrap any regular object that you would create normally with a normal reference within the weak reference class, and just basically use it. One thing to mention is that you need to probably add some additional checks because the target of the weak reference can be null. And another thing is that probably you won't use it in a widget, for example, that gets rebuilt very often or at all, because at any point garbage collector can just collect this object and release it from the memory. So you have to be very careful with this one. We could also lazily initialize our objects. For example, with factory constructor, also getters, or even late initializer, using late initializer keywords. All of these basically boil down to the fact that they're all initialized only when it's necessary. And yeah, and these instances in these cases are created only once. Why not use mixins? For example, if you're dealing with, let's say, change notifiers like text editing controllers very often within your app, like you have many screens where you have to use them, and why not create a mixin that actually handles the disposal of these objects instead of doing it manually inside each stateful widget. Again, need to mention that it will mostly always depend on your implementation of your needs within the app. Whether or not it makes sense for you, I guess it's up for you to decide. But that's, in my opinion, this is one of the techniques that you can get creative with most if you decide to actually try it out. The obvious one, you need to discard of the resources used by the object. In dispose method of, for example, stateful widget, as you can see in the code snippet, you have to dispose of the text editing controller. You can cancel subscriptions, close syncs, and so on. This is manual work, but it's highly effective. So you just have to be aware of it, not to forget to do it. Yeah, using const constructor. So use const constructor whenever and whenever possible. Why? Because, well, first of all, constants get allocated during the compile time, which is a recommended optimization and also performance gain. And secondly, whenever you create two identical instances with a const constructor, it will actually create one instance and reference the others. For example, if I create like speaker 3, and it's again like the same constant, it will actually reference the first one that was created. Okay, so you have two examples in front of you. The left one, to your left, pure Dart, and on the right, your right again, with Flutter widgets. So I want you to raise your hand if you think in the first case, on the left side, it will print out true. I guess you didn't understand the question. So what's going on in the print method is we are comparing if the object speaker1 is identical to speaker2. So can you raise your hands again if you think it will print out true? Okay, not what I expected, but it will work. Yeah, it will print out true. So what about example on your right side? I want you to raise hand if you think those two objects are also identical, if it will return true. Can you raise your hands? Okay, tough crowd, I guess. But it returns false, so like you're probably thinking like, what is this guy on about? Like, how it can be, they're like literally the same object. You can see, you can compare the characters, like size box, like what's happening? So the thing is that in debug mode, the const canonicalization happens differently than it does in release mode. And this is because of the added support for debugging tools in debug mode. So in release mode, it will actually return true. Release mode, I said that, yeah. So it will actually return true. And And the thing is, you don't have to worry about it because in debug mode, still the const canonicalization is performant enough, and you still get all the gains, all the performance gains from it. On the other hand, const canonicalization. So this is specific to widget widget constant canonicalization. With regular constants, it works well in either build mode. So, a few minutes back, we checked out leak tracker and the most common leak types that it tracks. So the fixes for them are fairly simple if you are able to locate the source of the leak. So for objects that are not disposed, but they were garbage collected, all you need to do is call the dispose method on the object. As I said previously, it can also be close or cancel for different objects. And for objects that were disposed but not garbage collected, or for whatever reason they were garbage collected later than they should have been, you need to assign reachable objects reference to null after disposing of the object. So let's do a quick recap of what we discussed today. When does the memory leak happen? Whenever app fails to release the unused memory and make it available for any future allocations. What is a reachable object? It's an object that has at least one reference pointing to it, meaning that it's still in use and it cannot be garbage collected. What is an unreachable object? It's the opposite of reachable object, and it holds 0 references and it can be garbage collected. What can we do to detect the source of the leak? There are like few options. Either you're a complete code wizard and you can just open the code, look at it and say, okay, this is where it's leaking, then great for you. But for me, it's easier to use debugging tools provided by Flutter and Dart teams, like DevTools Memory View in combination with Leak Tracker package. And what can we do to potentially prevent those leaks? There are various memory optimization methods. These are just few of them that we looked at today, but the most important ones probably are proper resource disposal within the stateful objects and using const constructor whenever possible. Yeah, you can, if you want, you can search for my apps on either App Store or Google Play. Thank you for listening. Yeah, I hope you learned something. If not, maybe you brushed off the dust on some forgotten concepts. Let's talk afterwards if you are interested in something that I said. But thank you. Yeah.
Thank you, Raitis. Do we have any questions for Raitis? Put your hands up.
Can I run this on the CI in a headless emulator, this memory leak analyzer?
No, unfortunately, you need a real device for this one.
Okay.
Yeah.
So I'm Flutter developer, so I know about the dispose stuff. It's like pretty typical stuff. It's common mistake. But I was wondering about how you caused the leak of the large objects in your example.
Just by generating basically a large number of, basically it generates 10 million integers and creates an object. Like the basic class, it creates an object and stores it in a list of a singleton object. And in this particular example, it never gets disposed of. So, or
okay, but the list still lives somewhere, so somewhere which is like a leak per se.
I'm not sure I understand the question, but can you maybe try to explain in other words? But
I'm mostly familiar with leaks from like languages that don't have garbage collectors. So when we talk about leaks in garbage collector languages, it's already quite surprising to me. I was just wondering whether there was some nuance in Dart code which can actually accidentally cause a leak in the sense that this object is actually like somewhere in the ether and you will never be able to dispose of it again.
I mean,
but it seems like that's not the case. It's mostly just the leak tracker helps you find places where you have accidentally not released any object.
Yeah, basically yes, but we didn't use leak tracker specifically to track leaks for instances that were created with the blue button that generates the large list of the objects. But yeah, this is basically an example to illustrate that how leaks would normally happen. I guess I could actually upload the code as a GIS to my GitHub page later on, and you can maybe check it out yourself if you're interested. So, yeah.
Yeah, I understood the concept now. It just wasn't clear at the beginning. Thank you.
Okay.
Okay, any more questions? If not, then you can catch Raitis in the networking space. And thank you, Raitis, very much. Okay, just to have a couple of last words. Our next Mobile Developers Latvia meetup is happening in August. And we will have Karin talking about probably Kotlin, since she's a GDE in Kotlin. And we're always looking for speakers, especially local speakers. So if that's something that you want to try out, let me know, let Chili Labs know, find someone from us, and we can talk. And because we're always trying to become better for you, we will really, really, really appreciate if you take your phones out and scan this code and fill in the small form with feedback. This is your chance to impact how the next meetups will go, who will speak, what will be the topics, and so on and so forth. Okay. So have a couple of last questions. Did you like the meetup? If yes, then please clap. Okay, awesome. And then let's go chat more, connect more in the networking space.